Howdy, and welcome back to Yates American B244. We're going to get the spindle and motor assembled one last time and do a run-up test. Except for one little problem. Well, despite putting these nice oilers in the pressure bar and chip breaker rings, I'm going to use some dry graphite lubricant on them and on the sleeves where they get mounted. This mask is held on with some Super 77 that I let get tacky for a few minutes. How these rings are assembled onto the sleeves is kind of important. So when I was taking the cutter head apart, I took a picture and made a drawing of how these rings go together. And so on the drivetrain end, the pressure bar ring is oriented like this, with this flat boss this direction. And then the chip breaker ring is oriented this way. And then on the motor end, it's just the opposite. The pressure bar ring is oriented to the outside with this boss towards the outfeed side. And then the chip breaker is opposite. So this is how the rings will go on, and then the bearings get mounted on top of them. This bearing was not going on very quickly, so I had to switch to an 8-pound sledge. I'm not going to tighten any of these until I get the motor housing on the other end. However, I'm going to tighten these bearing housing bolts. I'm a little bit surprised and disappointed that there are no alignment pins on this bearing housing on the drivetrain side. You know, I hammered those 2 pins in on the motor side, but this side actually has quite a bit of play, so I'm not sure where the right location is. I guess I'll try to find a happy medium. This one doesn't have quite enough room for the socket to get on there. I found a deep socket that's just skinnier enough to fit on there now. Wow, that is so much quieter than the original bearings that I refurbished for the motor test. That's nice. I need to clean out this groove preparing to put on the stator, and a high-speed steel cutting blank worked out just perfect to scrape out the gunk from that groove. Okay, I've checked and double checked this set screw on the fan here. And here we go with the rotor. The rotor pretty much snaps on like a Morse taper. I was putting the spacer washer on here and realized that it's banged up a little bit. Like everything else on this machine, it's been abused and hammered on. So I'm going to go offline and clean it up a little bit. I'll get a new bearing lock washer in a few days, but for now I want to go ahead and get the motor to where I can give it a test. I don't know if I've shown this before or not, but a friend of mine on OWWM sent me a motor starter to use for the cutter head motor. I'm going to repair a couple of holes that are in this motor starter case. You might recall from early on that I was able to refurbish one of the original motor starters, and I'll have to build a case for it and set it over here somewhere. But this is the motor starter for the cutter head. Okay, I've got the rotary phase converter running over there and wired up to the starter. I have the wild leg of the phase converter running through the left-hand heater, which does not run through the starter circuit. Between L1 and L2, I've got 250. Between L1 and L3, I've got 265. So L3 is that wild leg I was talking about. And then between L2 and L3 is 260. So again, L3 is a wild leg. Okay, since I don't have the thermal overloads in place, I need to hold these thermal overloads down while I do a test of the starter. It's got a little bit of a kick. Okay, for my motor test, I've temporarily got the heaters disabled because I don't have the thermal overloads yet. Motor leads 1 and 7 tied together. Motor leads 2 and 8 tied together going to a terminal, and then motor leads 3 and 9 going to a terminal. And then I have motor leads 4, 5, and 6 tied together. So that's configuration for low voltage, 240 volts. Like with the first motor test, I'm going to spin up the cutter head with a rope in order to reduce the startup load, because my rotary phase converter is only rated at 5 horsepower and this is a 7.5 horsepower motor. In addition, I've got some tape holding these rings back because I don't want them to drift into the rotating cutter head. Here we go. Well, that's still kind of noisy, but it's a lot quieter than when the old bearings were on it. While it's quieter now, I'm noticing severe vibration. Vibration on the left frame is bad, but it's worse on the right frame closest to the motor. I'm suspecting it's caused by that outboard motor fan that was previously broken and then repaired. Well, just temporarily, I'm going to eliminate this fan as a factor in the vibration. So I'm going to remove it and put a spacer to replace it and put the bearings back together. Okay, I've got it running now without the outer fan there that was broken and repaired. And it's still vibrating, but it's definitely not as bad. Okay, I'm not real sure what I'm going to do about the vibration problem. I could disassemble the motor and try to statically balance all the different components. My first inclination is to see if I can get it dynamically balanced as a professional service somewhere. As it stands, if I were to buy this machine and it was vibrating like that, I wouldn't buy it. So I think getting that vibration taken care of is kind of critical, just from a usability standpoint and from a durability of the machine standpoint. Anyway, stay tuned, and we'll see what we end up doing with this spindle and all the vibration that it's producing.